Today we're going to talk about weather maps. Weather maps cover a lot of information, but what we're going to mainly focus on is what can we tell from a weather map and how do we predict something on a weather map. While we're going through this lesson, I want you to think, how can you use a weather map to explain global weather patterns and influences on local weather? And also, how can we interpret the low and high pressure areas and what type of fronts are shown on a weather map? First, to understand a weather map, you must understand air pressure. So air pressure or atmospheric pressure is going to be the pressure caused by the weight of the air above you. Pressure is going to decrease with the height above the earth. So as our elevation increases, our air pressure decreases. We measure air pressure by using a barometer, and those barometers are going to measure it in millibars. An average barometric pressure at sea level, which is kind of where we are here in Gulfport, Mississippi, it's going to be about 1,013.25 millibars. High pressure is going to be anything higher than that. Low pressure will be lower than that baseline average. Areas of high pressure are going to be caused when air cools and becomes less dense, so it sinks towards the Earth's surface, spinning clockwise. Low pressure is going to be as air warms, it becomes less dense and rises above the Earth's surface, spinning in a counterclockwise rotation. So here, I want you to look at these two pictures. What do you notice about the colors of high pressure and the colors of low pressure? Why do you think they are colored this way? High pressure is in blue, whereas low pressure is going to be in red. That is because high pressure is going to be when air cools. And when you think of the color blue, you think cool weather. The low pressure is in red because low pressure typically is going to be warmer and humid. So red, you think of heat, which is why low pressure would be colored red. High pressure systems are going to bring us sunny, clear skies, calm winds, cool, dry air, and it's really going to be the better kind of weather, the kind of weather that we want to see. Low pressure is going to bring those clouds, storms, stronger winds that are going to be spiraling in a counterclockwise rotation. It's going to have that warm, moist, or humid air, and the pressure is going to be lower than normal. If you look here on this map, you describe what type of weather you would have in a high pressure system moved into your area. So here we see this area of low pressure, and here we see this area of high pressure. This low pressure has the storms occurring, and high pressure is sunny. So if this high pressure system moves into this area of low pressure, that will push away the storms, so we have sunny, calmer weather. On a weather map, we have isobars. Isobars are going to connect points of equal atmospheric pressure. On this map, you can see these lines here that all connect the different areas of like pressure. Some of the most common low pressure systems that we see are going to be tornadoes and hurricanes. Both rotate in that counterclockwise rotation like we said low pressure systems do. Also on a weather map, you'll notice that we have different types of air masses. Some air masses, which are large bodies of air that have relatively uniform or same humidity and temperature. These are some examples of our air masses. We have continental air masses like these that form over land, and maritime air masses like these that form over water. Cold air masses are going to approach us from the north, northwest, or west. Warm air masses typically will approach us from the south, southeast, or east. When we're talking about these air masses, you also talk about frontal movements. This is going to be when cooler air masses or high pressure that are more dense flow towards areas that are less dense and warm, moist air. High pressure areas move to low pressure areas. Also on a weather map, you'll find different fronts or different types of weather approaching. These are going to be the boundaries between two air masses. They're going to be classified by what type of air is replacing the air previously there. They will have the symbols, or here you'll notice the half circles or triangles pointed in the direction in which they are moving. We have different types of weather fronts: cold fronts, warm fronts, stationary fronts, and occluded fronts. A cold front is going to be cold air replacing an area of warm air. The air behind the front is going to be cold and dry. The air pressure is going to increase as a cold front comes through. That moist, humid air is going to be pushed up over that cold air. Showers and thunderstorms will form along the edge of a cold front and typically dissipate fairly quickly. A warm front is going to be when a warm air mass overtakes a cold air mass. Behind a warm front, there is going to be that warm, moist air, and the pressure is going to go down. These are generally slow-moving fronts that will have the warm air rise over the cold front. This is going to cause widespread and continuous precipitation, not like when the cold front came through. This is going to have a continuous amount of rain and precipitation over a period of time ahead of this warm front coming in. A stationary front is when two air masses meet that are not strong enough to push the other one away. This will cause light rain over several days. And then a occluded front is going to be when two air masses that are cold take over a warm air mass. This is going to occur very quickly, and it will have thunderstorms generally associated with the beginning of it. After the first line of thunderstorms goes through, though, you'll have the cool, dry air of a cold front. Looking at this map, let's look and see what type of front do we see coming through. Here I have cold, and here I have warm air. I notice that my different triangles and half circles are pointed north, so I would move this over and rotate it this way, showing that that warm air would be overtaking this. Or you could have done it the other way, where the cold air mass here is moving over this way, which is generally how weather would move. That is all I have for you on weather maps. Hopefully, you can now look at a weather map and at least know what some of these instruments and things are that we use when we're predicting weather.